Hello students, in this video we're going to go over some examples from section 2.4 on measures of variation. So in this section we're going to discuss three measures of variation. So we're going to discuss the range, the variance, and the standard deviation. Okay, so according to the book, the range of a data set is the difference between the maximum and minimum data entries in the set. So to find the range, okay, we're going to take the maximum data entry and then subtract from it the minimum data entry. So remember, the maximum data entry is the largest value in the data set, and then the minimum entry is the smallest value, and that's in that same data set. So let's go ahead and take a look at an example from your homework. Okay, and this is question 1 in the homework for section 2.4. All right, and here you see what's called a dot plot of a data set, and the question is asking you to find the range of the data set represented by the graph. So let's go ahead and enlarge the graph so we can see it better. So this is our dot plot. And the nice thing about a dot plot is that you can actually see what the individual data values are. So for example, there are 1, 2, 3, 4 data values equal to 80. Okay, there's 1 equal to 79. Okay, there are 4 data values equal to the value of 94. Okay, and so on. But to find the range, we need the smallest data value and the largest data value. Okay, so it looks like the smallest data value is 75. Okay, because that dot is on the far left of our dot plot. And there are no other dots to the left of it, so 75 is the smallest data value. Okay, likewise, the largest data value is represented by this dot. There are no other dots to the right. Okay, so 100 is the largest data value. Okay, so our range is going to be 100 minus 75. So to be on the safe side, I'm going to do that on the calculator, but you can certainly do that in your head. So 100. So 100 minus 75 will give us 25, so the range of our data set is equal to 25. So from the smallest value to the largest value is 25, and that's what the range represents. And there's no need to simplify our answer. Okay, so let's look at the next question, so which is question 2. All right, the problem says that the age in years of a random sample of shoppers at a gaming store are shown. So we want to determine the range, mean, variance, and standard deviation of this data set. Okay, so before we proceed, let's go to the ebook and see what the book does about determining the other measures of variation. So remember that other than the range, right, there is the standard deviation and the variance, which are also measures of dispersion. Okay, so the other two measures of dispersion are discussed starting on page 83. And it'll walk you through how each one is calculated. Okay, so it'll walk you through how to calculate the variance and the standard deviation of a data set. Now, the important thing to remember is that we're not going to use any of the formulas in this section to calculate the variance or the standard deviation. However, we may need to use our calculators to do certain things. Like, for example, if we have the variance of our data set, then we can use it to calculate the standard deviation pretty easily. Likewise, if we have the standard deviation, right, we can use our calculators to calculate the variance. So we're mostly going to use StatCrunch to get these measures of variation. All right, but in some cases we may need to use our calculators. So unfortunately, the computer is a little slow, so the page is freezing or really sluggish, so I apologize. So the book starts by talking about what a deviation is, and you can read about it. And then it talks about what the population variance is, and likewise what the population standard deviation is. Now keep in mind that you would only calculate the population variance or population standard deviation, right, if you have, okay, so continuing on, right, if we have an entire population of data, then we can use these formulas to calculate the variance and standard deviation of the data set. So very rarely in statistics are we going to have the complete population of data available to us. So let's go on to the next page. Okay, and it tells you step by step how to calculate the population variance, which is given by this formula, and then the population standard deviation, which is given by this formula. But keep in mind, since we are rarely going to have access to an entire population of data, we're not going to make reference to these formulas. So since we're most likely to have a sample of data rather than data from an entire population, right, what we're going to focus on is calculating what's called the sample variance and the sample standard deviation. Now, we're not going to use these complicated formulas, so what we're going to do instead is use StatCrunch. But if you want to know how this works out by hand, right, you can follow these steps on page 85. Okay, so let's go back to the problem. And you're going to click on the little icon to the right of the data set to copy the table. Okay, so you can either open it in StatCrunch, or you can copy the data. Okay, and with the data highlighted, hit Control C or Command C to copy it. Okay, and with an empty spreadsheet in StatCrunch, we're going to go ahead and paste the data. Now, starting in the very first row, so you can select any column in which to paste that data. Okay, so I'm going to go ahead and select column 4. And then on my keyboard, hit Control V or Command V. Okay, and there's the data set from the problem. Okay, so what we want is the range, mean, variance, and standard deviation of this data set. Okay, so we're going to go to the Stat menu, go to Summary Stats. And because our data are in a single column, we're going to select Columns. Okay, select the column that contains the data. Okay, and we want the mean, variance, standard deviation, and the range. Okay, so again, since we're selecting multiple statistics here, right? Again, when you do this, as you select each one, right, make sure you hold down the Control button or the Command button on your keyboard to select multiple statistics. So I'll select the mean, okay, variance, standard deviation, and the range, and click Compute. Okay, and let's go back to the question. Okay, so remember the range is the largest value minus the smallest value, so you can probably eyeball the largest value and then eyeball the smallest value, and then subtract the two to get the range. But when we do this in StatCrunch, okay, it'll give it to you automatically. Okay, so the range is 11. Okay, now we want the mean. Now keep in mind that the mean is not a measure of variation; it's a measure of center, or measure of central tendency. Okay, but the problem is asking for it anyway. Okay, so going back to our results in StatCrunch, we see that the mean is 17.7. So the problem perhaps asks you to find the mean, because if you do this by hand, if you calculate the variance by hand, right, you need the value of the mean if you're going to use the formulas in the book. Okay, so the mean is 17.7. Okay, so the variance, we can quickly get in. Okay, so the variance is 12.45. Okay, and you want to be aware that in blue it'll give you directions for how to round your answer, since if you don't follow those directions closely, even if you have the correct answer, it might mark your response as incorrect. So it's telling you how to calculate the variance using the formula from the book, which is obviously not what we're going to do. Okay, so if you read the directions in blue carefully, it says that we want to round this to the nearest tenth. Okay, so the first digit after the decimal point is a 4. Okay, that's the number in the tenths position. Okay, and the next number over is 5. So when we round this to nearest tenth, it's actually 12.5. Okay, and remember the standard deviation is the square root of the variance. Okay, but we don't need to do that because it gives us to it anyway. So the standard deviation to the nearest tenth would be 3.5. Okay, and that completes question 2 from the homework in section 2.4. Okay, let's go and look at the next question, which is question 3. All right, and it says compare the 3 data sets on the right. Okay, and part A asks which data set has the greatest sample standard deviation. Sample standard deviation, right, is a way of measuring the variation in the data set. So the standard deviation is the average distance the data values are from the mean. Okay, that's what the standard deviation is measuring, right? The average distance from the mean, okay, for all the data values. Okay, so if you view these graphs closely, okay, and the dots might be hard to see, but basically you've got 4 data values equal to 14, 6 data values equal to 16, and then 6 data values, right, or actually 7 data values equal to 15. Okay, so all these graphs look roughly symmetric. Okay, so basically you're looking for the data set that's more spread out than the others. Okay, now in graph number 1, the data values are all fairly clustered around the center, which should be the mean. Okay, so that one's not going to have very much variation. So when you look at the other two, right, you're looking mostly at, okay, right, which data set is more spread out? The data set that's more spread out is going to have the higher standard deviation. Okay, so for this data set, since the graph is symmetric, okay, the mean is going to be in the middle, which in this case is 15. And then on either side of the mean, you have 1, 2, 3, 4, 5 data values on either side of the mean. Okay, this one you have the same number of data values on either side of the mean. However, you only have 2 that are further away. And then here you have 4 data values that are further away from the mean than the others. Okay, so it's actually going to be graph 3 that has the higher standard deviation. Okay, and then using kind of the same reasoning, which data set would have the least standard deviation? So using that same reasoning, right, you look at the graph of the data that's more clustered around the center or around the mean, okay, which is in the middle of their graph. So example 1 would have the smallest standard deviation because the data values are more closer or more clustered around the mean than the others. Okay, and then lastly, how are the data value sets the same? How do they differ? Okay, well, they all have the same mean of 15. Because the data sets are symmetric, the mean, median, and mode are all equal, but their standard deviations are different. So it's option C, that's the correct, and that completes this problem.